Now we have a few remarks on smart cities and or ubiquitous cities. And as far as I know, the word ubiquitous means the same thing as smart here. And the idea is just sensors everywhere. We saw that in the Dublin vehicle example from IBM. And Korea is a leader here because the small size of Korea and the high density use of smartphones makes it a particularly and very, very good wireless connectivity and cell phone connectivity everywhere in the country makes it a natural place to implement this type of technology. So we will do, after we do the ubiquitous city, we'll do smart grids, which is basically the idea of adding IT to all the electrical power networks. And I say these are all cases where knowledge comes from integration of data. Um, Robots actually, everything is in a single place, but then these vehicle networks or these city networks, then all the sensors are pretty distributed. But in all cases, the idea is you have multiple sensors and you're linking them together with by various algorithms. In the case of the glaciers, that we were linking together the different depth measurements on different points of the glacier to get a complete bed of the glacier. Um, so you join the, and so the analytics is going to be different in each case, but always we're getting knowledge and wisdom by joining data from multiple sensors together. So here I just took a few slides from a talk from Korea, which is about the vision of the ubiquitous society in Korea. And this is just a statement about Korea. I already pointed out why it's particularly um, a good place to look at ubiquitous cities, just because it has first in broadband access per capita. It's got a pretty high scientific literacy. It's obviously a very vigorous technology society with the good IT industry. Samsung is well known as a major Korean company with a lot of cost progress in smartphones and tablets and related things. And their point is that all this technical leadership is not clearly matched in terms of prosperity for the population. So maybe ubiquitous technology can help them increase that. And they point out that this is something that people often note, that the young people today may not think quite the same as old people. For instance, this obsession with privacy for health data we did in the last unit. Other people say that's just the day. In a few years, you'll just have young people. Those young people have grown up with Facebook. They're not so hung up with privacy. And so that whole area will be less important. And so all this is pointing out that part of the ubiquitous city is Facebook, Twitter, etc., and how they're linked together using tiny client devices. So the government in Korea considers ubiquitous devices very important, where you basically everybody is enabled with computers and phones and things, and around them the monitors are basically helping them have a better life. Quite how it should be done and what those monitors should do, where they're really important, remains to be seen, I think. There is one example here, which is ubiquitous life. Is in this new city, Songdo, with and it's meant to be finished in 2014. So this is a rather old article, 2005. It's not. I do not actually know. We should have to check how realistic that is. And then the last section of this unit is on the smart grid, which comes from a selection of slides taken from a course at Illinois. This course is much bigger than, I give you the full link here. I just have a few slides to illustrate some of the key ideas. So Here the professors in charge of this course. It was a 2010 course, but at the level I'm discussing it, I think the points made are correct. Um, so it notes that the US electricity grid is aged, centralized, very fragile, and it needs to be upgraded with distributed sensors, and centralized cloud computing. Um, and an example was there was a very famous blackout in 2003 in the Northeast, which was due to the failure of the grid. That one failure was cascaded into other parts of the grid, and then the whole thing collapsed. And that affected 55 million people and lost 6 billion, cost 6 billion, and in general, every year 135 billion is lost due to power outages. And of course, the US is well known to have aging infrastructure. It's not just its electrical grid, its roads, its bridges, its buildings are all aging because it actually expanded earlier than many of the emerging countries. So you will get pretty more modern infrastructure in other parts of the world. But the US has made a choice, and it's got aged infrastructure. So trying to improve that infrastructure without rebuilding it all from scratch is pretty important. So smart grids are very straightforward. You take all the collection of items on the grid, all the different transformers and transmission lines and meters and things like that, and you just internet enable all of them and send that data to the cloud, and you use that for the consumers to use their energy more efficiently, for the power producers to know when they have a problem, and to also do selective power offs in an efficient fashion when they're on those days when more power is needed than is actually available. And they do not then have to switch on inefficient sources of additional power when it's quite as much. So this points out some of these features. As I say, it's all here's the grid across the country. We obviously have to worry about security, because if it weren't secure, this IT infrastructure would be used to destroy the grid. We need to make it so that everything is distributed and self-healing. So this is a classic autonomous processing problem, because and the IT information is intrinsically reliable. You have multiple sensors, so if one goes down, you can effectively interpolate to find the values from other sensors, and all of this is controlled dynamically. Hopefully, it's cost effective. And because it's all software and it's all done by software, it's sort of intrinsically flexible if you write the software correctly. Here's the type of devices you have. It's advanced metering infrastructure. It allows real-time electrical pricing, accurate load characterization, and outage detections. And so this is a smart meter, which was in California, asked their utilities, for example, to deploy. Here's the some more technical device, a health monitor, phasor measurement unit, which measures the electrical health of the system and detects faults early, isolates faulty systems, and prevents unnecessary power outages. This is the type of thing that would have prevented that Northeast power outage, not the original power outage, but just the cascade effect. Here's an example of weather. We know, of course, a lot of the problems with power come from bad weather, and you not only want to predict bad weather, you also want to know when your solar energy will be and wind energy will be effective. And this is the final vision, that we want to have self-sufficient energy with wind and natural gas, renewable energy, and all of this can be integrated together with this type of infrastructure. So this allows a more richer set of electrical power producers to be supported. So these are relatively clear reasons to do the smart grid, and clearly the electrical utilities are looking very carefully at it. I don't think they're using clouds at the moment, but they ought to be using clouds. So that's the end of this unit. And as we say, there are 24 billion sensors in the Internet of Things by 2020. They all ought to be linked up to the cloud. And that will provide them, the cloud will give them enormous performance, and the 24 billion devices will give a lot of use for those clouds. Thank you very much. That is the end of this unit.